And we're talking about now about our test equipment and accessories. Here, Conprove solution to test relay protection. We can test transducer. We can test matters. We can test marriage unit and PMUs, and do tests based on traveling waves. About digital substation, we can test, diagnostic, and monitoring digital substation. Here, there are some equipments we'll see in details ahead. Here is our model that do secondary tests. It's a three-phase test set. We have here 3 currents up to 32 amps. We have 4 voltage. We have 12 binary inputs that can be used as analog input too. We have 4 binary outputs and some special sensors for low level. And we can inject low level too. We can do IC650 test too. And it's a very lightweight. Here it's our bestseller, is the 6710. We have here 6 current. It's 6 current for 32 amps each one, and 4 voltage up to 300 volts. We can do tests on IC650 this equipment can inject and can publish sample value and GOOSE message, and can subscribe sample value and GOOSE message too. We can do tests for calibration matters, transducer, quality matters, and reproduce ATP files, contract files, PCAP files, and do a lot of tests for protection, like verify the trip time for distance 21, differential 87, and others. Here is other model, the 7012. This hardware can inject secondary and primary level. It can test CTs, VTs, transformers, circuit breakers, up to 6 current, up to 50 amps each one. We can inject in one phase up to 300 amps, and 6 phase for 330 volts. With just one phase, we can inject 2 kVs, 2000 volts. We can do tests on IC651 too. The same condition, we can publish and subscribe GOOSE and sample value. We can test transducer and all. And this kind of equipment have a special condition that because we have 6 current and 6 voltage too, we can test the end-to-end test in a lab with just one test set, because we have 3 voltages and 3 currents that can be used to test one side, and the other 3 voltage and other 3 currents we can inject in the other side. It's about our test set for digital substation. It's the 67 net. We have here binary inputs and analog inputs, binary outputs, here low level, outputs and inputs. And we can inject, publish and subscribe GOOSE and SV. It can be used to detect packet loss, monitor the IC650, verify PTP messages, compare the SL files with the network traffic. The other one is the MNet4 that was used on the UCA test. And with this equipment, we can do all the tests in the digital way. This test set just have Ethernet ports, don't have binary inputs, and they do not have binary outputs. It's lightweight. We can put it in the backpack and travel with this. This one can simulate up to 60 stream of sample value, we can simulate 60 merging units in just one piece with just this test device. And this can verify and do all the analysis and diagnostic of the process bus and the network traffic up to all the sample value frames compared to the SL file. Here are some highlights from Conprove. We can simulate errors with our test set to verify the behavior of the ID that was tested. We can verify if the behavior losing of sample value, GOOSE, and PTP. I will jump one slide to show to you how it can work. Here we can inject and publish some sample value with packet lost, with packet delay, with duplicated packet sample value, a corrupted sample value packet, errors in quality. We can change the simulation bit. We can lose the synchronization, change the sync flag in the frame. All of these conditions can be done during the test. We can inject the fault and change all these parameters to simulate an error on your Ethernet communication network. For GOOSE 2, we can simulate packet lost, packet delay, duplicated packet, corrupted packets, and message loss. And for PTP2, we can simulate errors when we have the ability to verify the grandmaster. We can be done a grandmaster clock, and from our grandmaster, we can simulate grandmaster clock occurs change, grandmaster class change, grandmaster ID change. We can change to verify the behavior of the slave. Here, other highlights, we can subscribe the sample value. It's a very good condition because with our test set, we can inject the analog value on the merge unit and get back with the same device the sample value and compare with the sample value that we are receiving the accuracy of the merge unit, verify the angle error, the amplitude error, verify the digitalized time, and verify the time between frames with just one device. It's a very good condition that can be done with our test set. We can publish multiple PIUs simultaneous. We can simulate a lot of merge units with the model 6710. We can simulate up to 10 merge units with the same device. And with the CM-MNet4, we can simulate up to 60 merge units in the same device. The 67net and the MNet can be used in both ways. We can do tests with this. We can be a test set for a digital signal, sending sample value and verifying the GOOSE, and can be done in the other way. We can diagnose and analyze the network to verify any errors. Here we already see this type of errors. About the synchronization, we can use our test set in a slave mode, and we can use our accessory like this one. This one is the GNSS. We can synchronize our test set with this, or we can use the signal from the PTP, the Precision Time Protocol, and the test set can be synchronized with the Ethernet cable, and we can synchronize with another GPS with iRigB. We can read the iRigB in a binary input and synchronize our test set. And there's an option with the GPS inside. We have here in the back an antenna to put here, and with the integrated GPS, we can synchronize the equipment. And when we are working in a master condition, we are the grandmaster, we can use the PTP protocol to synchronize others. In a lab, we can synchronize with the test set, and we can inject the iRigB to verify the condition too.